Hello, everyone, and welcome. We're so excited to have you here for another great session. We hope you've had a really great time seeing lots of different sessions. I hope you caught the last keynote, got a lot of great research information from that one. And we're in for a really great session again. This is Future Proof Your Agents, and Breno Brito will give us all the great information. But before we get started and I hand it over, just want to remind everyone that please feel free to post your questions or comments in the chat. And then there's also a Q&A area as well if you want to add questions there. So we welcome your interaction during the presentation. And I'm going to turn it over to Breno now. And thank you so much for presenting today.
Hello, everyone. Thank you so much for being here. I really appreciate the opportunity. And my presentation is Future-Proof Your Agents program, don't prompt with DSPy. The idea here is a little bit trying to explain why DSPy and kind of making a speed run. This is a very lots of slides, so I hope I can get to the end so we can answer some questions. But before that, my name is Breno Brito. I'm from Brasilia, Brazil. I'm a machine learning engineer / data scientist. I'm also a technical meetup host. Also, I have a book on Bitcoin because I also worked in lots of Bitcoin companies. This is also a main point of interest. This is my information. It's always Breno RB in X, in LinkedIn, Gmail, so you can reach me out later. So let's get into it. Just table contents. We are starting with some context, and then we are going to dive deep inside DSPy and explain basically everything. So let's get into it. So context. Several projects that I've been doing since 2023. They usually lots of people advise not to use any framework. However, I kind of disagree a little. There's lots of things that I don't think it's good that we have to re-implement. However, every framework that I was using, they were opaque. An LLM is just strings in, strings out. Like most of them, there's of course multimodal, but let's focus right now just the just text ones. So if I don't know what's getting in, it's difficult to steer the model to make it it turns out the best things possible. So the most of the frameworks that I tried were very opaque. It's hard to version as well. There's you're building writing prompts and testing prompts. Sometimes you're testing so much that you get the worst prompt that you started, but you didn't save because it's not good to be committing everything in Git. It's kind of hard to do it. So it's a not so good thing. Also, almost all frameworks they have hard-coded prompts. So all these frameworks that you just like write a line and it's ready to use agents. They have lots of hard-coded prompts, and this can work best for one model than to another. Some models work better with if the prompt in the library updates when you update the library. This could be bad for your system. It can maybe not work so well. And also it's hard to inspect, evaluate, debug intermediate steps. Sometimes they are doing lots of things. I've talked with some companies, they are doing this. The models are doing so much that they cannot even understand what they are doing. So it's really hard to scale the system. But also prompting itself is a problem. inside a prompt. A prompt is basically a huge wall of text, and we have input structuring, an inference strategy, output structuring, detailed context to definition, demos, tasks, and other things. But also every week we get a new state-of-the-art model, and but the models they require different prompting techniques. Most of the models, lots of models, they release also a guide to better prompt the model. So you have to if you change your model, you have to like redo all this work on prompting, and also they can require new prompting strategies. They can require new structures. Even the two definitions can we can get new structures, and we can maybe need to reword, and there's always the bitter lesson applied for prompting that AI may be better, prompt better and faster than you. So the main idea here is maybe instead of wasting your system design time rewording prompts, maybe you shouldn't waste your system design time rewording prompts. You should like work on your system and then you improve your prompts. You optimize later. So like you get a huge prompt. How do you even maintain this? Like this is completely different from every kind of engineering perspective. Um, so and how this is why I like DSPy so much. DSPy stands for Declarative Self-Improving Python. It took me years for me to learn, but the documentation is improved since then, and it's way better to understand now. And also, I'm bringing this digest, and it's hopefully it will be really easy for you as well. So basically, um, there's four main abstractions. We have signatures, we have modules, we have adapters, and we have optimizers. So in this picture that I'm showing to you, um, the signature is basically the task or the intent, the input output, and we wrap this task in the inference strategy, which is a module. And the adapter formats these signatures and modules together to get it into a prompt, an initial prompt. And this is basically it, and you can use it as it is. You can create more modules and stack each other, but also there's this optional part where you can optimize your prompts, and we'll get there and understand how it all work out. But this is a very systems engineering practice. So first of all, we get the signature. It's a task. Is what you want the model to do. It's the intent that you want. It's just inputs and outputs. So the signature is this blue part over here, and when we put this into code, it's basically this. Is this small string here that I put tweet in the input and happy in the output. And I also put an optional type that I said that the happy is a boolean. So that's it. I'm going to input a tweet and I'm going to get happy as output, which is a boolean, so it's true or false. And so that's it. You already know how to use DSPy. Thank you for coming to my lecture. I'm kidding. There's a little bit more, but this is the basics that you can already do so many things with it. So there's of course a little bit of setup, basically one line to choose your model, and another line to use this instantiated object, so you can reutilize this using lots of different tweets. And it gives us a prediction object, which is happy equals true. So it's very simple. In 3 lines, you have your product, your model working. And of course, we can get a little bit more complex. Instead of just like happy bool, we can also put confidence float. So now we input I'm so happy today, and we get our response is a prediction object with happy equals true and confidence equals 0.95. And we can check the types, and the types are correct. Output is bool, and the class of the output of happy, the class of happy is bool, and also the type of confidence is float. So this everything that it's we cannot see on this library, DSPy, is everything that you don't need to see. It's just making sure that you get the correct type, you get the correct structure, you get a good structure every time, the types that you want every time. So that's basically it. You don't need to think about it. So let's get a little bit more complicated, a little bit more complex. So let's say I'm getting an email, and I want to get a list of tasks that email send me. So I put my input is today, which is a string, email, which is a string, and then task, which is a list of strings, and then the deadline, which is a string. A nice thing that in this example is that by how you define, how you name your variables, for example, deadline, YYMMDD, the model will how to output this to you. Look here that I didn't say anything about, I didn't made any steering. I could use Pydantic, for example, and say that I want exactly this output, but I didn't. But since this is going inside the model, the model, of course, will understand that deadline YYMMDD is that I want a date, which is the deadline, and a year, month, and day. So that's exactly what I get here, already formatted as I wanted. Of course, we can make another validation stage, but for most cases, especially in the beginning, it works wonders, and it's very, very good already out of the box. And okay, but if I have lots of inputs and lots of outputs, I would have to have a really big string here, and we are getting into the first problem again. And of course not. We can use a class, a signature class, and we can structure a little bit more and have more information in this signature, in this task, what you want. So basically, the docstring is part of the code. So the docstring is an instruction that goes into your model. It's important for you to know that. There's also inputs, which is just an input field. It's basically the same as a Pydantic field. And so the attachments here, we can have a more complex type. So for example, here is a dictionary of strings in mapping into DSPy.image. So we can input an image here. We don't need to make lots of different conversions. So this works also for images and for audio. There's types for that, and you can easily work with them without using lots of boilerplates. What I like from DSPy is that it abstracts all of your boilerplates. And of course the outputs, so we get a list of events. We can define the events in another as a class somewhere else and use it. And also the action items with the action, and also the priority. which I put here as literal. So I will always get P0, P1, and P2. So this also steers my model to specific outputs and specific types. And I can, for example, if I'm doing a classification, I can use literal and use the classifications here. So I know that it will never invent a new classification for me. It will always output this type here that I just got it. So you could put an enum, for example, and so this is amazing for me. And of course, there's this desk, which is description, so you can explain a little bit to the model what is the input, what you want for the output, so you can have a little bit more specific details on this. Okay, so that was everything on signatures, basically almost everything. And what are modules? Modules are inference strategies, but also building blocks. What is an inference strategy? So we were it's this blue part and this yellow part. I just showed you some code that use this DSPy.predict and extract events. So predict is the most basic, simple module that exists, but it's also an inference strategy, which is basically not using any inference strategy. You just like prompt your model and that's it. However, you can use other kinds of inference strategies like chain of thought. So the model will use a chain of thought. Uh, you can use this batch module that is a little bit more complex um, module that will get these email threads and run in parallel. Lots of you can run as many as you want depending on your computer and what you want, but you can run lots of things in parallel. So this extractor is your instance, and you can use batch and to use lots of email threads instead of just one at a time. Also, you can use React. So you change just one line here, one method, and now you got an agent. So you use here your React, you can give tools. Tools are basically Python functions. You don't need to wrap them in anything. You don't need to put them inside a decorator or in a special function or do anything. Just write a Python function and you put here, and it's a tool, you can use it. Best of n, it run n times. This is 3, for example. You run extractor n times, and then it gets you the best one according to this reward function that you can just invent here. Is just another Python function. And so each and every one of these is a module: predict, chain of thought, react, best of n. So, and this is a very simple thing, but you can go a little bit more complex. Just like we did in signature, we can use a class from the DSPy module. And if you are looking at this, if you use PyTorch, it's very similar to what you used before in PyTorch. You have init init method and forward methods. So basically, you declare what you are going to use in init, and then you use it in forward. And so this is the hop method that use this thing here, and it gets clean here. You can see that in forward it uses clean, so you just use hop clean equals to, and you pass what you want, and it will do this logic over here and give you back what you want. And this is very cool because when we are in the next phase in the optimizer section, you'll see that we don't need to optimize every prompt in every for every signature, we optimize the program. So we don't want an overly optimized task. We want an optimized system. We want to everything to work really well, considering the other parts to get the best response possible. So this is what so when we optimize, we can optimize this high order module here that will optimize everything inside for you automatically, so you don't need to think about it. And this is very good. Okay, so but I was telling you about like how the other ones are bad, they are opaque. We cannot see what the prompts are. So let's take a look into adapter so we understand what is going on, what is the actual prompt. So we have signatures that we wrap them in modules, and we use adapters to format them into prompts. So when we don't say any, when you, the default adapter is the chat adapter. When you don't define any adapter, this is the one that it's going to use. So for example, using this context manager here, we can use that old tweet sentiment program, really simple one. I can ask it to generate some kind of response, and I can use this DSPy.inspect history and see what went inside the model and what the model spit it out. So this is what the model formats it. So I just insert tweet, goes to happy, which is a bool, and confidence, which is a float, and it creates all this system message and all this user message here, and we get this response here, and that's how it can parse and everything and have it structured for us. And I'm not going to spend a lot of time here because it's kind of simple and you don't need to actually look too much at it because we're going to optimizers and you understand why. But there's a JSON adapter, so it will try to format things in JSON. Some models work better in JSON, some others models work better in XML. So you can use it to give you this format here. But also there's this very interesting one which is a two-step adapter. It will format not only the system message but also the user message with instructions. So it's more it usually adheres to your prompt better if you're doing some very complex thing. Sometimes you need to use the two-step adapter and it will work instead of the other ones. So this it's a maximum steering force, let's say it like this. But also you can create your own adapters, but it's a little bit complicated at the moment. But usually those one work. So okay, we are now in optimizer phase. We already have a program that that works, that makes implements all of our logic in our system. So everything is working, but we want it to work even better. Maybe we want to change models and try a little bit better, change strategies from predict to chain of thought, and other things like this. So one way to do it is, I believe maybe the best way to do it is going to optimizers. And first of all, let's explain just a little bit what we need. We need, of course, a data set, which is basically an example. It's DSPy.example, and we put the inputs and the outputs here, and we give to the model what are the actual inputs. And after we have this data set, of course, we need to evaluate. If we want to optimize, we need to evaluate how it was and how it is now after optimizing. So there's this evaluation part of the library. where you can put your set. You can do it in parallel, and you give a metric. Again, the metric is just a Python function. It's very, very simple. So this is a simple, very simple LLM as a judge. I put the judge here, and I just use it to output this, if it's similar and how confident it is. So this is just a simple example. Let's go to the actual to the actual optimization strategies. So the simplest one, it's Bootstrap Few Shot. Everyone that knows prompt engineering knows that the simplest way to improve your prompt is to give some demos, some examples, which is known as few shot prompting. So this is an automatic way to do a few shot prompting. It selects the best. You give a set, and it selects the best examples to use in your prompts, and it compiles and adds as a demo inside your program. The second one is a MiPro, is a little bit more complex. I won't get into the detail. I just want you to know that it exists and you can then study it later. But basically, it's a multi-prompt instructional proposal optimizer. So it gives lots of different prompts and instructions, and it proposes lots of prompts, and it tries it out. And there you can give a teacher, then will help to steer the how it will improve your prompts. Also, there's Simba, which is the stochastic introspective mini bash ascent, which is something like the other one. It uses a little bit of base, but also you give your program. You have a student, you can have a teacher, and then some metric, and it will generate lots of instructions, lots of prompts, and try the best ones according to your metric. And GEPA, lots of people are talking about GEPA. It's also the same thing, but it uses a genetic Pareto. But also, you should read about it in the documentation, the website later. But what I think it's very, very interesting, not saying that this is the best thing, but it's if we want to optimize, why do we need to optimize just the prompts? We can make a fine tuning, because fine tuning is the same. We give examples, inputs and outputs, and we run some code and optimize our system. So we can do this for this. We can use this bootstrap fine tune and actually have a fine tuning update your weights of your system, not only your prompt. So you can use both. For example, you can update the weights and also the prompts. But also you can use, for example, GRPO, which was made very famous by DeepSeek. Uh, it seems very big, but actually it's just you define your variables, you instantiate the class, and then you run the optimizer. It's the same. It's simple. The complex part is just the variables that you need to work it out. But it's inside the library. You can just run it, and so you have inputs and outputs. You can do whatever you want. You're not restricted just to prompting. So this is something that I find very interesting from DSPy. And of course, don't forget to save your program. You can use save and load. So with DSPy, you can easily keep up with the latest tech. You just change a line, you change a strategy, you change a task, you add a little bit more, and you can version it. You can keep it future proof. Just like you maintain software, you can maintain your AI software without needing to have all the all wall of text that is so complicated to maintain. So that's it. Thank you so much. If you want to try this code, I have it here in this link that you can follow. You can follow me on Twitter, send me an email, and I will try to answer if you do it. Thank you so much.
Thank you, Breno, for this great presentation. We really appreciate it. And I hope everyone has a wonderful day. And please continue to join us for sessions.